Hello, students. Our lesson today is coming to us from Unit 10, Lesson 5, and it's on multiplying rational expressions. Our benchmark, MA 912 AR 1.9, it says to apply previous understanding of rational number operations to add, subtract, multiply, and divide rational algebraic expressions. Our learning targets. I can multiply rational algebraic expressions, and I can determine domain restrictions of a rational algebraic expression. So let's look at some guided instruction. Here we have an expression, and they are asking you to tell if the two expressions are equivalent to each other. We have x to the third over 4y times y to the second over x. So down here, they put it together here. That gives us x to the third, y to the second over 4 times y times x. So this is like subtracting same base that have exponents. That lesson we did on the laws of exponents. They want to know if what we have circled here is equivalent to this expression to the far right, x squared y over 4. So yes, it is. If we took the x to the third and we're dividing it by x, that gives us x to the second. And the y squared divided by y gives us y. That stays in the numerator. My denominator has a 4, and that doesn't have anything to cancel out or to divide. So we leave that 4 in our denominator. So yes, these two expressions are equivalent. They are equal to each other. Okay, so let's look at number 2. Let's factor the numerator and denominator of both expressions in the table. So let's do the first expression. We have 3x minus 6 over 2x plus 3. So let's take our numerator, the top expression, 3x minus 6. We have to say to ourselves, what's the greatest common factor between 3 and 6? Give you a second. That's right, 3. So we should end up with 3 on the outside when we're factoring, because that's what we're factoring out, dividing out. And in parentheses, we will have x minus 2. Sorry, guys, it's so hard writing on these screens. X minus 2. In my denominator, the greatest common factor between 2 and 3 would be 1. So because it's 1, it stays 2x plus 3. Sorry about the terrible handwriting. Excuse me. Excuse me. So that would be factored. That's the factored form. Okay, let's look at the second expression. We have 5x plus 15 over 4x plus 8. Let's start with our numerator, the top expression. What is the greatest common factor between 5 and 15? That's right, it would be 5. So we have to factor out a 5. So 5 on the outside, and in parentheses, we're dividing each of our terms. 5x divided by 5 gives us x. And then plus, keep the sign that we have, 15 divided by 5, which is 3. And that would be over, we have 4x plus 8. Greatest common factor between 4 and 8 would be, that's right, 4. So we factor out a 4, and we will have x plus 2. Very good. Here's your answer slide. Easier to see. I'll give you 30 seconds. All right, let's move on. So here now we have this expression. We're multiplying the same expressions from the table, and we're going to be multiplying them excuse me, to see what the results would be. So they want to know if we would circle the expressions that could give the result of the two expressions from the table. So 3x minus 6 over 2x plus 3 times 5x plus 15 over 4x plus 8. Okay, so I would say this is one factor, this is one result, and then the factored form would be this result. So both of these expressions are equal to each other when those are multiplied. Okay, so let's fill in the blanks to justify our choice. The greatest common factor, GCF, of the numerator and denominator, that would be 1. After the GCF is reduced from the numerator and denominator, the product in simplified form is, here it is, we have 15 times x minus 2 times x plus 3 over 4 times 2x plus 3 times x plus 2. Okay, I'm going to give you 20 seconds to go ahead and write this down. Make sure you have this in your notebooks. All right, guys, good job. Let's move on. Okay, let's look at this example. Complete the following to find the product of the two expressions in the lowest terms. The first row has been completed. So here's at the top in the gray, that's your expression. We are multiplying x squared plus x minus 12 over 8x plus 72 times x plus 9 over x squared minus 4x minus 32. So here are the steps to follow when multiplying these expressions. Here's step 1. Factor your numerators. So start with the numerators. The one on the left, x squared plus x minus 12, and then the one on the right, x plus 9, and see what we can factor. So the x squared plus x minus 12 can be factored out to x plus 4 times x minus 3. The x plus 9, it's already factored, so that will stay x plus 9. Okay, the second step is to factor our denominator. Both denominators. So the one on the left is 8x plus 72, and then the one on the right, x squared minus 4x minus 32. So start with the one on the left. Let's factor that. Greatest common factor between 8 and 72. That's right, it's 8. So we're going to factor out an 8. And that, when we factor it out, we're dividing each of those terms by 8. The first one, when we factor, it will give us x plus 72 divided by 8 is 9. Okay, let's try that again. 8 parentheses x plus 9. Awesome. Okay, so let's factor x squared minus 4x minus 8, 32. So we can use any method that we've done before with factoring. One method, I can multiply my a, which is 1, times the c, which is 32, and that will give us 32. And then we find factors of 32. When we subtract them, we get 4. So I know 4 and 8 gives me 32 when we multiply, and when we subtract, we get 4. So we know two parentheses. Need to have two parentheses. Both have an x in it. And because that middle term is a minus 4, I know my 8 is going to be minus and my 4 is going to be plus. So that is factored. So now step 3 is to write the factored form. So the numerators, x plus 4 times x minus 3 times x plus 9 over our denominator, which we just factored, where we have 8 times x plus 9 times x minus 8 times x plus 4. Okay, so now next step is to set the denominator equal to 0 to determine the domain restriction. So this is how we find what our domain restrictions are. So just what's in the denominator, each of those expressions in parentheses, we set them equal to 0. So let's start with the x plus 9. We set that equal to 0 and solve for x. So when we solve for x, we get negative 9. That means our denominator for x cannot equal to negative 9. Let's take the second one. We have x minus 8 equals 0. And when we solve for that, we get x equals 8. But we can't make x equals 8 in our denominator. And then the last one is x plus 4 equals 0. Solve for that. X cannot equal to negative 4. So those are our domain restrictions. Step 5, it says to reduce any common factors that exist in the numerator and denominator. So when you look, we have an x plus 4 in the numerator, x plus 4 in the denominator. We can cancel those out. And then in the numerator, we also have x plus 9. And in the denominator, we have x plus 9. Is there anything else that we can cancel out? No, that's correct. So what's remaining, we have in my numerator, x minus 3 over 8 parentheses, x minus 8. So that's in factored form. I'll switch to the next slide so you can see it much better. I'll give you 20 seconds to go ahead and write this down. All right, our 20 seconds are up. Let's move on. Okay, that was step 5. This would be step 6. Let's multiply through the numerator and multiply through the denominator. So my numerator only had x minus 3, but my denominator had 8 parentheses x minus 8. So multiply that out, we get 8x minus 64. So now to check to determine if the resulting expression can be reduced further, if so, reduce it. So this right here, this cannot be reduced. Any further. And that's step 7 is to check. All right, let's look at example 6. We're going to find each product and reduce to lowest terms. We're not going to do letter B, just letter A. And then state the domain restrictions. So we're going to multiply 5x over x squared plus 5x plus 6 times x squared minus 4 over 10x. Okay, so let's start with the numerators. So we have 5x, and then the other side is x squared minus 4. If we factor that out, we should get x plus 2, x minus 2. That's over, that's just my numerator. Let's look at our denominator. So for the denominator, we have the x squared plus 5x plus 6. Let's see, we can factor that. So take my a, which is 1, multiply it to my c, which is 6. And that's 6 times 1, which is 6. And find factors of 6. When we multiply them, we get 6. When we add them, we get 5. So that would be 3 and 2. So here we have x plus 2 times x plus 3. And then our 10x can't be factored any further. All right, so now we're going to take the next step. Let's take our denominator, set each of our factors equal to 0, and see what our domain restrictions are. So we have x plus 2 equals to 0, and when we solve for x, x cannot equal to negative 2. Okay, the next one is x plus 3 equal to 0. That means x cannot equal to negative 3. And then 10x equals to 0. When we multiply, x cannot equal to 0. So there are our domain restrictions. Now that we know that, we can simplify. What can we cancel out? So we have x plus 2 in the numerator, x plus 2 in the denominator. Those we can cancel. And also we have 5x divided by 10x. That gives us 2. And that would stay in our denominator because the bigger number is in the denominator. Okay, so let's see what's remaining. In my numerator, I have x minus 2. And that's over in my denominator, 2 parentheses, x plus 3. So that's in factored form. Let's multiply through the numerator and multiply through the denominator. So that will give us, in my numerator, is just the one factor, x minus 2. And in my denominator, we have 2x plus 6. This would be our results. Let's move to the answer slide so you can see it. See our domain restrictions. X cannot equal to negative 3, negative 2, or 0. I'll give you 10 seconds to go ahead and write this down. All right, our 10 seconds are up. Let's move on. So let's look at this guided practice. It's asking us to find the product and reduce to lowest terms. So we have 4b minus 12 over 3r plus 6 raised to the negative 2 power, and then multiplying that to b squared minus 2b minus 3 over r squared plus 4r plus 4. So here we have several things happening. First thing we need to look at is that negative exponent. Going back to those laws of exponents. the laws of exponents, especially the negative ones. How do we change from a negative exponent to a positive exponent? That's right. We have to flip that fraction. So in doing so, we would end up with 3r plus 6 over 4b minus 12. Still keep that in parentheses, but now it's a positive 2 for our exponent, times the b squared minus 2b minus 3 over r squared plus 4r plus 4. So we have several factorings to do. Let's start with our numerator. So our numerator here, it tells us that we have 3r plus 6 twice. And then the numerator on the right side, when we factor that, factors of 3, when we multiply them, we get 3, but when we subtract, we get 2. So in each parentheses, we have a b. So it's 2 parentheses. One's plus, one's minus. So factors of 3, so that would be 1 and 3. Those are the only factors of 3. When we do subtract them, we get 2. So we have to place, so it's a negative 2. The 3 has to be negative and the 1 has to be positive. Okay, let's take our denominator. So we have 4b minus 12 twice. And we know we can factor those out. And then r squared plus 4r plus 4. So we know it's 2 r's, 2 parentheses, r's in each, and they're both positive. So that's r plus 2 times r plus 2. Okay, so the 3r plus 6 can be factored. So both of those can be factored. And if factoring out 3 and 6, greatest common factor would be 3. So that will give us the r plus 2 twice. And then do the same for the denominator. 4b minus 12, factor that. Greatest common factor is 4. And we'll have 4 parentheses b minus 3 for both. And then what we will do is take our denominators. So here we have 4b, and we only need to do it once, minus 12 equals 0. And solve for b. So we're adding 12 to both sides. 4b is equal to 12. Divide by 4. So b cannot equal to 3. And then we have the r plus 2 equal to 0. So r cannot equal to negative 2. Those are our restrictions, or domain restrictions. Okay, so on the next slide, it will show you the factored form. I hope this lesson was simple enough for you to understand multiplying rational expressions. Thank you. Have a good day.